Welcome back, learners. As you know, in the previous lecture, we have finally assigned the slab, and once the slab is defined, so it is properly assigned for our given problem. Now today, let us go for the next step, that is the application of your loads, right? Yes. Now for the first problem, I am considering only the two normal loads, that is your dead load and live load. When we take up another problem, in that let us consider when the earthquake is there, so how it has to be applied. So for the first problem, so let us consider that there is only two forces acting on the structure. One is the dead load, another one is the live load. Now the dead load, as you know, it is completely due to the self weight of the material. Okay, so the structure has to bear its own self weight. Along with bearing its own self weight, even the other loads which acts on the building also, it has to be resisted properly. That is your live loads. Now when it comes to the dead loads, in our problem we have majorly two dead loads. Okay, we have majorly two dead loads. So one is the dead loads of our beams, columns and slab. Okay, so the dead loads of our beams, columns and slab. Okay, so now when it comes to the dead loads of beams, columns and slab, it is based on the unit weight of the material. You know, the density of the material is of the concrete is usually we taken it as 24 to 25 kilonewton per meter cube. Okay, so that what we do, we usually convert it into the kilonewton per meter and we apply on the beams. But in the ETABS software, there is no any conversions of loadings. There is no any conversions of loading. When you want to assign the dead load, okay, when you want to assign the dead load of the beams, slabs and columns, the software will automatically take its dead loads. But when it comes to the assigning the dead loads of the wall, then we have to assign it on each and every beam by converting the unit weight of the wall, which is in kilonewton per meter cube, to kilonewton per meter. So that we will see here. First, let us complete the application of the dead load. So then let us come to the application of the live load. Now when I want to apply the dead load, right, so I have to first go to define. Okay, so in the define option, you can see that there is an option what you call it as load patterns. Okay, so in order to apply the dead load, what I am doing, I am going for the define, and in the define I am going for the load patterns. When I click on the load patterns, okay, when I click on the load patterns, you can see that there is one column to give the name, that is dead or live or any other type of load. You can see here itself that there are different types of loads. First is dead load, then another one is also super dead load, live load, reducible live, roof live, then notional, seismic, wind, snow, construction, pre-stress, final transfer and other, right? Like that there are different loads, and you can also multiply that by the corresponding factor. Okay, you can multiply that by the corresponding factor. Now combinations of the loads let us consider later, but first we have to define the dead load. So here the dead load is already defined, right? So the dead load is already defined, so no need to define again. If you want, you can delete this. Okay, you can, if you want, you can delete this and you can make that load as DEAD, dead. I'm giving the name for that dead load as dead, and I am choosing it as a dead load, and your self weight multiplier should be 1 and you should add. So therefore your dead load is added. Okay, your dead load is added. So after the dead load, you know, even the live load is also added. The first let us define the loads, then later we have to assign them. Okay, so therefore first I define the dead load. Now similarly I want live load, therefore I will go for live, and I have to choose here live. I have to choose here live. Then here there is nothing to be multiplied by factor. Why? We are going to multiply the factor later, so therefore we are not multiplying here. Okay, we are not multiplying here. So therefore only for the dead load it has to be multiplied. For live load nothing to be multiplied, you just add new. Therefore my final two loads, dead and live. Okay, my final two loads, whatever I require that has to be applied here, that is dead and live, I have defined them. I have defined the dead and live. You give OK. Okay. Now after that go to define, and in that you go to the last, what you call it as load cases. Okay, load case. Now here already, since I defined whatever I define here, for example whatever I define here in the load cases, okay, whatever I define in the load patterns, that will be projected there. So here I have defined only dead and live, so therefore only those two will be projected here in the load cases, right. So there you can keep this as it is or you can change it. You can see modify or showcase. Okay, so now the load case will be dead, the load case type will be linear static. So there are various ways, right, for your undergraduation level. So assume that the load is going to vary linearly. So when it is not going to vary linearly, then you are supposed to choose non-linear, static, non-linear, stacked, response spectrum, time history, buckling, historic, like that. So but my dead load usually we will be taking it as linear static. Okay, then so these things they are in default, so no need to change, you keep it 1. Even your live load also, so it will be as it is. Other than that, here also you have an option to add some new cases. Usually it cannot be done until and unless you define here. Once you define in the load patterns, then only you can go to your load cases, right. Now the one of the major advantage of the ETABS software is, once you define the dead load, so there is no need to apply the dead load to the members. The ETABS, during its analysis, it will automatically consider the dead loads of the beam, column and slab. No need to separately calculate and apply here. The dead load will be automatically considered in the software based on what type of material and based on its unit density. So the software will analyze and it will take the dead load of the beam, the dead load of the slab and the dead load of the column. But here you can see when I go to the 3D structure, I have nowhere applied the wall. I have nowhere applied the wall, right. So therefore I want to up here, you can see that there will be a wall here. So there will be a wall here. So that wall load also it has to be applied on the beams under dead load only, because wall is a dead load. So therefore separately only the dead load of the wall has to be added here. Only the dead load of the wall has to be added here. Now, if I go to the IS code 875 part 1, okay, if I go to the IS code 875 part 1, the 875 part 1 will give you the unit weight of the different construction materials what we use in our day-to-day life. All kinds of construction materials which is usually available in the market, their unit weights are available in the IS 875 part 1. The IS 875 part 1 is only for the dead loads. It will give you the unit weight of the materials. By knowing the unit weight of the materials, you can convert it into the corresponding type of load. Either you want to convert it into the floor load, or either you want to convert it into the uniformly distributed load. So that you can do and you can apply here. Okay. So therefore here I have to convert it into the unit weight of our wall load into the uniformly distributed load, right? So what I will do, you can see here that there is a wall here. Whatever this wall is there, this wall load has to come to this beam. Now the unit weight of the wall will be given in kilonewton per meter cube. When I want to multiply that to kilonewton per meter, when I want to multiply that by kilonewton per meter, just what you are supposed to do is you have to multiply that unit weight of the wall material into the height up to which the wall is constructed. It means my height of the wall here is 3 meter. So therefore the unit weight of the material of the wall, which is in kilonewton per meter cube, has to be multiplied by the height of the wall. So when I multiply by the height of the wall, I will get it in kilonewton per meter square. Then after that I have to multiply it by the thickness of the wall. So when I multiply it by the thickness of the wall, then again I will get it in kilonewton per meter, which is uniformly distributed load. That kilonewton per meter uniformly distributed load will be applied on these beams. Okay. So now you understood that. For example, now I will tell you. Now I am using a cement concrete blocks as my walls. I am using the cement concrete blocks as my wall. When I use the cement concrete block as my wall, as per IS 875 part 1, the unit weight of that material, okay, the unit weight of that cement concrete block material, okay, the unit weight of that cement concrete block material is usually taken as 20 kilonewton per meter cube. It is usually taken as 20 kilonewton per meter cube. Now when I multiply that by 20 kilonewton per meter cube into the height of the wall, which is 3 meter, I will get 60 kilonewton per meter square. 60 kilonewton per meter square. Now what is the thickness of the wall that I have taken? What is the thickness of the wall I have taken? The thickness of the wall usually what we have taken is 230 mm. That is nothing but your 0.230. Okay. For example, that means what is the meaning? It means it is 230 divided by 1000 will give you 0.230, which is the thickness of the wall, multiplied by 3, which is 0.69. That multiplied by unit weight of the hollow concrete block usually taken from 18 to 20. So let us take 20. So which gives you 13.8 kilonewton per meter. Okay, 13.8 kilonewton per meter. That UDL I have to apply on all the beams. That UDL I have to apply on all the beams. Right. So now let us see how to apply that UDL on all the beams. Okay. Yes. Now, so as you know, now the walls is constructed here and the wall is constructed here, but there is no any wall which is constructed at the top, but there will be a presence of parapet wall. Usually the thickness of parapet wall will be maintained as that of the thickness of main wall, but the parapet wall will be considered only on the outer boundaries. You can see any apartments or any multi-story building at the top, in order to have the safe protection, okay, in order to have the safe protection, usually the parapet walls are considered only on the boundary at the roof level. Okay, so they are constructed only at the roof level. And you know, the height of the parapet wall will not be same as that of the height of the wall which is constructed below. Usually the height of the wall which is constructed in the floors will be around 3 to 3.5 meters. Okay, that is nothing but equal to your height of your floor. But when it comes to the height of the parapet wall, usually the height of the parapet wall will be maintained around 3 to 3.5 feet. That means I can say 1 to 1.5 meter. Okay, so therefore first we will apply the loads of the walls of all the floors, then at the top we will go to the parapet wall. Okay, so therefore what I will do, I will keep the structure in the story. Okay, I will keep the structure in the plan, then I will go to this story 3, that is at the plinth level. Right, here I have to apply the load. Now how to apply the dead load? See, as I already told, the dead load of the beam, the dead load of the column, the dead load of the slab will be taken automatically by the software, but this load we have to apply manually. So for that what you have to do is, you have to go to assign. Okay, you have to go to assign. Now whenever I am applying the loads on the beams, we call that as frame loads, and whenever I am applying the loads on the slab, we call that as floor load. So since first I am applying the loads on the beams, we call that as frame loads. Therefore I will go to assign. In the assign, now I will go to frame loads. In the frame loads, I have to choose whether the load that I am applying is a point load or a distributed load or a temperature load. Okay, so now here whatever I am applying, it is an uniformly distributed load which is in the form of kilonewton per meter. Therefore I have to choose from the frame load, I have to choose distributed. Right. So now when I choose distributed, this dialog box will appear here. Now you can see that you have to choose the load pattern, whether that distributed load I am applying is a dead load or a live load. So you know it is completely dead load, therefore I am applying dead load. And it is forces, it is not moments, it is forces. I have to choose forces. If you are applying the moments, I can choose moments. If you are applying the forces, I have to choose forces. Right? And what is the direction of the load application? The direction of the load should be downward, that is parallel to the gravity. So therefore you can choose along the gravity, or if you want to change the direction of the loading, you can change the loading direction also. Right, whether you want to apply any load in X or in Y or in Z or some other planes, but for me it should act along the gravity, therefore I will choose gravity. Okay, now right, so if I am applying any variable loads, that is uniformly varying load, then I have to choose this one. But here whatever I am applying is in the form of uniform load, therefore no need to choose here nothing, I have to go for the uniform load. But the only difference is there whatever we calculated, it is in the form of kilonewton per meter. So now that I have to convert it to kilopascal per feet. So now let us see how to convert. So if you want to convert the kilo pascal per feet, okay, if you want to convert that to kilo pound, sorry, it is KIP means kilo pound per feet, right? So what I have to do, I have to just enter the value. Now I want it the kilonewton per meter. So my kilonewton per meter when I calculated was 13.6. So I will apply the value 13.6. So when I apply the value of the distributed load, that is kilonewton per meter as 13.6, then my kilo pound feet, okay, so kilo, just a minute. Yeah, so when I convert it, I will get around 10.5 kilo pound per feet. Okay, I am getting around 10.5, so kilo pound per feet. So therefore I will apply the value 10.5 kilo pound per feet. Okay, so before I have to do this, I have to select the beams. Okay, without selecting the beams I cannot do. So now I kept one story and this is my plinth beam. So therefore I will select the beams like this. Okay, I want the wall load to be applied on all these beams. So therefore I am selecting the beams, right? Yes, so once I select all the beams like this, I am selecting each and every beam. Right, so then what I have to do, after selecting the beams itself, I can apply the load. Okay, I can apply the load like this. Yes, so my plinth beams are selected. So now you go to assign, in the assign frame loads, in that distributed, then I have to go to uniform load of 10.5, apply OK. Right, so you can see that everywhere that value is showing. If we bring it to 3D, we can cleanly see that the loads on the plinth beams has been defined. Okay, so this is on the plinth beam, that is whatever this wall loads are there, that is ground floor wall loads, that has been applied on the plinth beam. Now then this wall loads also I have to apply on this beam. So therefore now again I will go to plan, right? So this load has been applied. So now I will go this, then again I have to choose the walls here. Here wall is there, here wall, here, here. So now again I have to choose all the walls. Right, so I am choosing all the walls, internal as well as external walls. Okay, so once these walls are chosen, then again you go to assign. So in the assign, go to frame loads, in that distributed, then again you apply OK. Right, so now when you go to 3D, you can see now Here again the walls of this floor has been assigned. Okay, the walls of this second floor, so it has been assigned properly, right? So this loads has been assigned on this. Okay, yes. So now when it comes to your top floor, that is when it comes to your parapet wall, so there when I convert that, what I am going to get, you can see there it is thickness will be maintained 230 by 1000, no change, multiplied by, there instead of applying the 3 feet, let us apply 1.5 feet. So you are getting 0.345 multiplied by 20. So that will give you 6.9. Okay, so that will give you 6.9. So when I convert that 6.9, which is in kilonewton per meter, to kilopounds per feet, it will come around 2.8. Okay, it will come around 2.8. Therefore now what I will do, I will go to the top floor, that is your, now this is ground floor, this one, now I will go here, right? After this you can see that nothing is there. So here the loads are applied only on the outer walls. Above this there is no any walls, only the parapet walls at the outside, right? So therefore I will choose only the outer walls. Okay, I will choose only the outer walls like this. So like this, only the outer walls of the structure will be chosen. Okay, yes. Right? Yeah. Right. So only the outer walls of the structure is chosen. Okay. So once the outer walls of the structure is chosen, then go to assign, and in the assign go to distributed. Okay, go to distributed, there you make it to 2.8, there you make it to 2.8, then you just apply the load here. Now if you see it in the 3D structure, you can see that on the top floor, okay, so the parapet wall load has been assigned, and in this your entire live wall loads has been assigned. Okay, so this is about the application of the wall loads. So similarly, in the next video we will learn how to apply the live loads, and once the application of the live load is done, so let us learn how to analyze the structure. After analyzing the structure, so let us learn how to study and how to proceed with the design. That we will see in the next video. Thank you, learners.